Today we're going to start Unit 10, and it says no packet number 10A for a reason, because we're only going to get half of Unit 10 done before break, and then the other part of Unit 10 will finish after break. But before we actually get into Unit 10, which is sequence and series, we're going to do a little review on some exponent rules when there are variables in the exponent. And I noticed that some people are still having problems with that, so I thought this would be a good time to go over it. So taking a look at the warm-up, basically the directions say to simplify. We're going to go right to letter B. 2 raised to the 3x plus 1 minus 3. All right, they want us to simplify. So we actually want to break up that exponent. Now we know in the world of exponents, addition means multiplication. So we're going to write that as 2 to the 3x times 2 to the first minus 3. Well, 2 to the first is 2, so I'm going to bring that to the front. So now I have 2 times 2 to the 3x minus 3. But I'm going to go a step further today. 2 to the 3x, well, 3x is multiplying exponents. I have a 3 times an x. And the only way I would get multiplying exponents would be the power to a power rule. So I'm going to rewrite it as 2 times 2 to the third raised to the x minus 3. I can simplify it even more. 2 times 8 raised to the x minus 3. I can't multiply the 2 and the 8 because 8 is being raised to the x, and I can't subtract the 3 from anybody, so that is the simplified term. All right, let's go to letter D. Letter D is negative 2 raised to the 2x plus 2. Well, the first thing I'm going to do here is actually factor out that negative 1. Now I know addition means multiplication in the world of exponents, so I'm going to write it as 2 to the 2x times 2 to the second. Well, 2 to the second I can actually figure out as 4 times 2 to the 2x. Okay, but I can multiply the negative 1 and 4 and get negative 4. Now let's take a look at that 2 to the 2x. Ooh, multiplying exponents, so again, power to a power rule. 2 squared raised to the x. So now I have negative 4 times 4 to the x. So there's my simplified form. Again, just a little bit of review. All right, let's start into Unit 10. Unit 10, we're first going to start off with what's called sequences. And sequences are nothing more than an ordered list of numbers. So it's following some kind of pattern. It's actually following some type of an equation, we can say. All right, sequences, ordered list of numbers. For example, 2, 4, 6, 8. Of course, you would say 10, 12, 14, 16. So the pattern here looks like it's adding 2, adding 2, adding 2. Okay? So if we look a little bit further onto our notes, they can either give it to you as the actual list of numbers, or with number 1, they can actually define it as an equation. And what they're saying there is a sub n equals 3n minus 1, where n stands for the number of term, or the terms, how do I want to say this? The term's number, whether it's the first term or the second term or the third term, that's what n stands for, the number of the term. Not the answer, the number of the term. So, what do I mean? Well, if you go back up to 2, 4, 6, 8, 2 is the first term. So he would be term number 1. 4 would be the second term, so he would be term number 2. 6 would be the third term. Do you see how this is going? Okay, so n stands for the number of term. The number of the term. And then you could say like first or second or third, yada, yada, yada. Okay, with that being said, they want us to use 3n minus 1 to find the first 3 terms of this sequence. Okay, I can do that. And the way we're going to do this, we're going to use what's called the chart method. We're going to set ourselves up a chart so it's easier to kind of look at. And it's going to come here, and that's the number of term that we're going to be looking at. 3n minus 1 is what we're plugging our term into. And the answer is going to fall here, which is basically our a sub n, which is our answer. So we're looking for the first 3 terms. So we need to find term number 1, term number 2, which is the second term, and term number 3, which is our third term. So we know our n's now, so we can plug it in. 3 times 1 minus 1 is 2. 3 times 2 minus 1 is 5. And 3 times 3 minus 1 is 8. So the first 3 terms of this sequence would be 2, 5, and 8. Okay, So now, which term would have a value of 80? Which means I have an answer of 80. So I actually have an answer of 80. And I know that the formula is 3n minus 1. So if I set myself up this tiny little chart here, I know that 80 is my answer. I know 3n minus 1 is my equation. What I'm looking for is my n. Which term is it? So I can say 80 equals 3n minus 1. Add 1. 81 equals 3n. Divide each side by 3. 27 equals n, which means 81 is the 27th term. Okay, let's go to the next page. Recursive sequences. A sequence can be defined by recursive definitions, which means when a sequence is defined recursively, its terms are found by using the previous term. So what does that basically mean? That means that if I wanted the fourth term, I need the third term in order to get the fourth term. If I wanted the ninth term, I'd need the eighth term in order to get the ninth term. So basically when we talk about recursive sequences, they usually give you the formula, but they always have to give you the first term so that you can actually then get the second term, because you need the first term to get the second term. And if you don't know what it is, you'd never be able to get the second term. So number 2, a sequence is defined by, so here's my formula, f of n equals f of n minus 1 plus 2. And here's my first term. F of 1 is going to be a negative 3. So they want us to find the first 5 terms. Well, this is going to probably be a bigger chart, so we're going to write nice and small because we have to actually fill things in, and then hopefully you'll get the hang of it. It won't be too much math. So n goes here. F of n minus 1 plus 2 goes here, and then my answer. Okay, so what do I know? I know my first term is negative 3. So I'm not putting 1 in for m. They told me what it is, because think about it. If I put 1 in for n, it would be n1 minus 1 is 0, and f sub 0, there's no such thing. Okay, so now I'm going to find the second term. So I have f sub 2 minus 1 plus 2. Well, f sub 2 is f sub 1. And what is f sub 1? F sub 1, we already know, is negative 3 plus 2, so my answer is a negative 1. So I needed that first term in order to get the second term. Okay, so let's make this go a little bit quicker now. So I need looking for the third term. So it's f sub 3 minus 1 plus 2. Well, f sub 3 minus 1 is f sub 2, and f sub 2 is a negative 1 plus 2, because that's the answer to f sub 2, which comes out to be a positive 1. Okay, let's do the fourth term. So this one's going to be f sub 4 minus 1 plus 2, which comes out to be f sub 3, and f sub 3 is 1, so 1 plus 2 is 3. So do you see how I'm using the answer of the prior guy to get the next guy? So the fifth term, f sub 5 minus 1 plus 2, well, f sub 5 is f sub 4, and f sub 4 came out to be 3, so 3 plus 2 is 5. So the first 5 terms of the sequence would be negative 3, negative 1, 1, 3, and 5. Okay, let's go on to the next problem here. For recursively defined sequence, t sub n equals t sub n minus 1 squared minus t sub n minus 1. Given t sub 1 is a negative 2, find t sub 5. So we have to find the fifth term. Well, it's recursive, so we have to actually start with the first term, get the second term, get the third term, get the fourth term in order to get the fifth term. All right, so let's set up our chart. So we have an n here. We have t sub n minus 1, the whole thing squared, minus t sub n minus 1. And here's our answer. Okay, so what do we know because it's recursively? The first term is a negative 2. All right, that's easy. So now let's do the next term. So the second term is going to be t sub 2 minus 1 squared minus t sub 2 minus 1. Well, 2 minus 1 is 1, so it's t sub 1. So let's write this one out. So it's t sub 1, the whole thing squared, minus t sub 1. Well, who's t sub 1? Yes, you're right. So it's negative 2 squared minus a negative 2, which comes out to be on the calculator 6. Okay, so let's continue on and hopefully we won't have to write so much math. So let's do the third term. So we have t sub 3 minus 1 squared minus t sub 3 minus 1. All right, so t sub 3 minus 1 is t sub 2, which is 6. So we have 6 squared minus t sub 3 minus 1 is t sub 2, which is also 6. So 6 squared is 36 minus 6 is 30. Okay, let's go to the fourth term now. So this is going to be t sub 4 minus 1, the whole thing squared, minus t sub 4 minus 1. So it's t sub 3, which is 30, and make that a nice 30. 30 squared minus 30, and if you put that in the calculator, it comes out to be 870. So now we have one more to do. So I'm going to move over here. Okay, so we're looking at the fifth term now. So the fifth term will be t sub 5 minus 1, the whole thing squared, minus t sub 5 minus 1. All right, so 5 minus 1 is 4, so t sub 4 is 870. Again, let's make that a nice 0. Squared minus 870, and I'm really running out of my chart here, which comes out to be, if you're on the calculator, 756,030. So again, in order to get the fifth term, we actually had to find the first, second, third, because we needed the fourth in order to get the fifth. Okay, let's take a look at the last problem on this page. Determine a recursive definition for the following sequence. Well, remember, it's a recursive definition, which means we need the first term in order to get the second term. So we have to look at the first term. We know that f sub 1 is definitely 5. So in order to get the next term, we take the previous term, and what are we doing it? So what are we doing to 5 to get 10? And then 10 to get, yes, you're right, you're multiplying it by 2. So we took the previous term and multiplied it by 2. So how are we going to write this? Well, it's going to be f sub n, or f of n, equals 2 times f of n minus 1. And again, every recursive definition has to have the first term given. So then we say f sub 1 equals 5. So our formula would be 2 times f sub n minus 1. Okay, let's go to the next page of our notes. All right, taking a look at number 5, the sequence is defined recursively using 2 previous terms. Oh, so now they gave us the first, which they have to for recursive, but they also gave us the second. Find the next 4 terms. Okay, let's set up our chart. And we know it's recursive. So this is going to be n. So it's f sub n minus 1 plus f sub n minus 2. And this is going to be our answer. Okay, so they said the first term was 1. The second term was also 1. That's a little odd. Okay, the next 4 terms. So I need term number 3. So it's going to be f sub 3 minus 1 plus f sub 3 minus 2. All right, let's see what I got. So this is going to be f sub 2 plus f sub 1. Well, f sub 2 is 1 plus 1 comes out to be 2. Okay, so the third term is 2. So now let's go to the fourth term. F sub 4 minus 1 plus f sub 4 minus 2. Well, f sub 4 minus 1 is f sub 3, or f of 3, so that would be 2, plus f of 4 minus 2 would be f of 2, which is 1. So 2 and 1 make 3. All right, one more for this one. And that'll give us, oh, no, we got a few more for this one because we have to go to 6 to get the next so many terms. All right, here's the fifth. So f of 5 minus 1 plus f of 5 minus 2. So it would be f of 4, which is 3, plus f of 3, which is 2, so that comes out to be 5. All right, let's do f of 6. So let's see here. So 6, so it's going to be f of 6 minus 1 plus f of 6 minus 2. So f of 6 minus 1 is f of 5, which is 5, plus f of 6 minus 2 is f of 4, which is 3, and then 5 and 3 make 8. Okay, so what are the next 4 terms? So 1 and 1 were the first and second terms, so the next 4 terms would be 2, 3, 5, and 8. Okay, hopefully you're fitting the charts in better than I am. It's just a little bit harder to write with a stylus. All right, let's go to letter B here. What is letter B saying? Letter B says, can you predict what the seventh term would be? Well, let's see now. If I look at this, it's the sum of the previous 2 terms, isn't it? Isn't it 1 plus 1 is 2? 2 plus 3 is 5. Okay? So 5 plus 8 would then give me, so let's write this down. So 5 plus 8, because that would be the 5th and the 6th, so the 7th term would be, you're right, the 7th term would equal 13. Because it looks like the pattern is adding the 2 previous terms, which it is, f of n minus 1 plus f of n minus 2. Okay, number 6. Find an algebraic formula for each of the following sequences. Now, they didn't say it was recursive, they just said it was a sequence, so we can take a look at letter A. 4, 5, 6, 7. 4 is the first term, 5 is the second term, 6 is the third term, and 7 is the fourth term. So, if I was working this out on a chart, I'd know f of 1 is 4, and f of 2 would be 5, and f of 3 would be 6, and f of 4 would be 7. So I've got to think now, what am I doing to 1 if I put 1 into an equation to get a 4? If I put 2 into an equation, I got a 5. If I put 3 into an equation, I got a 6. If I put 4 into an equation, I got a 7. You're right, we're actually adding 3 to that number of terms. So my equation would be f of n equals n plus 3. Okay, let's take a look at letter B. So what do we know here? We know the first term, so f of 1 is 2. F of 2 is 4. F of 3 is 8. F of 4 is 16. So let's see, what are we doing to the number term to get that answer? Well, that 1 doesn't help me. I'm not multiplying. Oh, it could be multiplying by 2. No, 2 times 3 is not 8, it's 6. Oh, I know what we're doing. Aren't we actually taking 2 and raising it to a power? Isn't 2 to the first 2? 2 squared 4, 2 to the third 8, 2 to the fourth 16. So my formula would be f of n equals 2 raised to the n power. Okay, not bad. All right, take a look now at letter E. I want to write a formula. So let's say here, what do I have going on? F of 1 is 10. F of 2 is 15. F of 3 is 20. F of 4 is 25. Am I multiplying by 5? 5 times 1 is not 10, it's 5, so that doesn't help me. It's going by 5s though. Am I going up by, no. Oh, I'm multiplying by 5 and then I'm adding 5. Let's see if it works. So it would be f of n equals 5n plus 5. So 5 times 1 is 5 plus 5 is 10. 5 times 2 is 10 plus 5 is 15. 5 times 3 is 15. Yep, it works. So my formula is f of n equals 5n plus 3. Okay, so now your job tonight is to finish everything I didn't finish up to page 3, even the 2 problems I didn't finish in the warm-up. And the first thing we'll do in class tomorrow is go over them. Have a good night.